All right, picture this. You're standing just a few miles away from a massive launch pad. The sun is just starting to peek over the horizon, and that booming countdown echoes over the loudspeakers. 3, 2, 1. Suddenly, millions of pounds of thrust absolutely explode beneath the rocket. Blinding fire shoots toward the ground, massive clouds of smoke billow out, and you can literally feel the earth shaking beneath your feet. And then, within seconds, this gigantic machine weighing hundreds of tons just majestically rises up into the sky. It's just a moment of pure, mind-blowing awe. Welcome to this explainer, where we're going to break down the absolutely amazing science that takes humans into space. But when you really look at that giant metal machine, you've got to wonder, how on earth can something so incredibly heavy fly without any wings? I mean, think about it for a second. There's no road up there, there's no runway in the sky, and there is definitely not some giant crane lifting this massive spacecraft up into the clouds. There's just fire, smoke, and an unbelievable amount of raw power. So how exactly does this whole thing work? Okay, let's dive into this. Section 1, the magic of liftoff. So let's look at how rockets solve this whole flying problem, because they do it in a totally different way than airplanes do. At first glance, you might think a rocket is kind of just like a giant airplane pointing straight up, right? But there is a massive difference in how they work. You see, airplanes rely entirely on their wings and their engines to push against the air in our atmosphere to fly. Without the air all around us, an airplane literally cannot get off the ground. But rockets, they don't need the atmosphere at all. Instead, a rocket carries everything it needs right inside of it. It basically packs its own lunch. It carries its own fuel and its own oxygen. Down inside those huge engines, the fuel and oxygen mix together and create this intensely controlled explosion of extremely hot gas. Because that gas is expanding so incredibly fast, it has nowhere to go but down. It escapes out the engine nozzle, and boom, that is what pushes the rocket straight up. To really picture how this works in your head, we gotta talk about a super brilliant guy named Isaac Newton, who lived over 300 years ago. He came up with what we call the third law of motion. Basically, it goes like this. For every action, there is an equal and opposite reaction. So imagine you're out on the playground, standing on a skateboard. Now pretend you're holding a really heavy bowling ball, and you throw that ball as hard as you can straight forward. What's gonna happen to you? You're gonna roll backward on the skateboard. The ball moves one way, and you get pushed the completely opposite way. Well, a rocket works the exact same way. The engine throws that super hot gas downward at crazy speeds, and the reaction to that action pushes the rocket upward. Now, what's really interesting about this slide is how we transition to Section 2, flying in empty space. So, how does this exact same playground physics apply once a rocket actually leaves our atmosphere and enters the black void of space? This brings us to a massive myth that we need to bust right now. A lot of people think that rockets need the air to push against so they can move forward. But here is the absolute truth. Rockets do not push against the air, not even a little bit. It's completely false. So, if there is literally no air in space, what on earth is the rocket pushing against to keep moving? It uses this incredibly cool concept called exhaust propulsion. Remember how we said earlier that the rocket packs its own lunch, carrying its own fuel and oxygen? Well, even in the total silent vacuum of space, those engines keep burning that mix and producing those ultra-hot gases. So the rocket actually pushes against its own hot exhaust gases. Those gases are blasted out of the back nozzle, and that reaction force just keeps pushing the rocket forward. In fact, believe it or not, rocket engines actually work way better in space, simply because there's no air resistance to slow them down. And that is exactly how spacecraft can travel millions or even billions of miles away from Earth. Have you ever watched a launch and noticed something falling off the rocket? That brings us to Section 3, dropping the dead weight. Before a rocket can go on a trip millions of miles away, it first has to escape Earth's gravity. If you've ever seen a video of a rocket launching, you might have noticed large, chunky pieces of the rocket just sort of breaking off and falling away as it climbs higher into the sky. Now, that's not an accident, and nothing is broken. It's actually a brilliant design trick called staging. See, the lower stage of a rocket is basically just enormous fuel tanks. Launching against gravity takes a ton of energy, but once all that fuel is burned up, those giant tanks are totally empty, and they become nothing but dead weight. Instead of hauling all that heavy, useless metal all the way into space, the rocket just drops them. By ditching the empty tanks, the remaining rocket becomes a whole lot lighter, and that means the engines don't have to work nearly as hard to push the rest of the spacecraft all the way up into orbit. Let's move to and see how this builds in Section 4, the secret to orbiting. Because actually, just getting up into space isn't the end of the job. A spacecraft has to be able to stay there. And to do that, it has to travel impossibly fast. We're talking 28,000 kilometers per hour. That's roughly 17,500 miles per hour. I mean, that is just a dizzying, mind-boggling speed. But that massive speed is exactly what it takes for a rocket to successfully orbit the Earth without crashing back down.
But what does orbiting really mean? A lot of people think things in space are just magically floating, but they aren't. At that crazy speed of 28,000 kilometers per hour, the spacecraft is actually constantly falling toward the Earth. Yep, falling. But because it's moving sideways so incredibly fast, the Earth, which is round, right, literally curves away beneath it. The result is just this continuous free fall. The ship keeps falling down, but the round planet keeps curving away, so the ship literally never hits the ground. It's like throwing a baseball so fast it just completely misses the planet. That's the amazing secret of an orbit.
Let's slow things down a bit for Section 5, Coasting Through the Cosmos. So, okay, we've launched, we've dropped our empty tanks, and we are officially orbiting. Let's take a breath here because I want to share a really surprising fact about physics. Once a spacecraft reaches space, its engines don't actually need to stay on all the time. I know, crazy, right? This is thanks to another one of Isaac Newton's brilliant rules, Newton's first law of motion. This law tells us that an object moving in space will just continue moving forever unless another force comes along to change its motion. Because space is a vacuum with almost zero air resistance to cause friction, a spacecraft can literally just coast. It doesn't need to burn fuel constantly like a car does on the highway. It only fires its little thruster engines when it needs to change direction, slow down, or maybe enter an orbit around a completely different planet. And this brilliantly illustrates exactly how we're able to explore the absolute deepest, darkest parts of our solar system. Because they can just coast completely fuel-free in the vacuum of space, deep space probes, like the famous Voyager probe, have been traveling through space for decades. Decades. They rely completely on Newton's first law to save enormous amounts of fuel, which allows them to just keep going and going and going, sending incredible pictures and data back to us here on Earth. So the crucial point is really this. A rocket works by burning fuel and oxygen to create super hot gas. That gas blasts downward out of the engine at tremendous speeds. And the reaction to that massive downward blast pushes the rocket in the exact opposite direction, straight up. And the craziest part? It does all of this with no wings, no air, and absolutely no pushing against the emptiness of space needed. Every single journey we take to distant planets relies entirely on these simple, powerful rules of physics. From the very first wobbly rockets ever built to the ultra-advanced spacecraft that are out there exploring distant planets right this very second, what you're watching is just the incredible laws of physics coming to life. The next time you watch a rocket launch, whether it's on a screen or in person, you are going to know exactly the magic and the real science that makes the whole thing possible. Thank you so much for hanging out with me in this explainer. Keep asking those big questions, keep looking up at the stars, and let your curiosity guide you. So what will you discover next?